Okay, this problem says that for time bigger than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t, and it tells us the position is 2 at time equals 4. So as with all free response calculator active questions, I'm going to insert the formula that is provided, the equation, into my calculator immediately because it's going to be useful somewhere or other, especially on these calculator active problems. Okay, I also see that I have to go up to time equals 4, so in the window I'm going to adjust my window to go from 0 to 4, and then I'm going to do the zoom fit, which is the 0 option, zoom 0, which provides the best picture possible on that particular domain of this function. Gets the mins and the maxes. Okay, so the question, part A, asks, at time equals 4, is the particle speeding up or slowing down? So to answer that question, I need to know what is v of 4, and I need to know what is the acceleration at time equals 4. Fortunately, since these are in the calculator, I can find both of these immediately just by going to calculate dy dx at 4. So I can read right here that the y is 2.979. That's the velocity. And I can see that the acceleration is given up here as negative 1.164. Negative 1.164. So we would say that the particle is slowing down since the velocity is positive, but the acceleration is negative. So remember, if the velocity and the acceleration have opposite signs, that means your particle is slowing down. If they have the same sign, then it is speeding up. Part B. Find all times in the interval 0 to 3 when the particle changes direction. Justify your answer. So this would again be a velocity type justification. So I'm going to draw a number line. And on that number line, I have to figure out all places where I change. So the velocity here is positive. It's above the axis. And then it changes here and here. So let's go find those points. Calculate the 0. 1, 2. That's between 2 and 3. That seems to be 2.707. 2.707. And at time equals 3 was supposed to be the upper bound, so I don't need to go all the way to the other place where it's 0. So I only had to go between 0 and 3. Now again, according to the graph here, I can see the velocity is positive over here and negative over here. So we can say that find all times the particle changes direction at time equals 2.707 because velocity changes from positive to negative. So that should be a full justification on part B. Okay, now let's go to part C. C asks us to find the position of the particle at time equals 0. So we know that the position at time equals 2 is 4. So the position at time equals t will be wherever it is at time equals 4, which is 2, plus an integral from 4 to wherever of the velocity function of v of, let's use a dummy variable here, v of x dx. So I know where it is at time equals 4, it's at 2, and then I can just add on the motion that happens on that interval. So if I want to know the specific position at time equals 0, then x of 0 would be 2 plus the integral from 4 to 0 of the v of x dx, which would be the same as 2 minus the integral from 0 to 4 of v of x dx. So I'm switching up the order just simply because it's a little bit easier to do in the calculator now, because I need an integral from 0 to 4, so I can calculate the integral from 0 to 4, and let's see what I end up getting for my area here. Nicely, it subtracts it nicely right there, giving me a total of 5.815 minus 5.815. So 2 minus 5.815 would be negative 3.815, which must be the position at time equals 0. Okay, last part, part D. Find the total distance the particle travels from time equals 0 to time equals 3. So again, consulting our chart, or sorry, our picture here, I can see that there are times when the velocity is positive and times when the velocity is negative. So there's places where it moves forward and there's places where it moves backwards. So I just need to add up the absolute value of the velocity to figure out what the total distance traveled is. It's important to do absolute value, otherwise I would be finding displacement. So in order to perform this, I'm going to go to Math and do my integral from 0 to 3, and I'm going to do the absolute value of the y1 function, because that's where I wrote it into my calculator. And the absolute value makes sure that all of the velocities are becoming positive, and that just gives me the answer of 5.301. So I would be saying in my justification, I'd be saying the integral from 0 to 3 of the absolute value of velocity of t is equal to 5.301. And that gives me the total distance traveled from 0 to 3.